No. How come? Because there's this y in here. So in the end, we only have, Lonnie, how many unknowns? One unknown. How many equations do we need? One equation, and we need how many bodies? One body. What body do you want to do? A, how come?
Because we know that C.
Okay, we don't know the angle of T, and all the forces come together there, right? So let's draw a free body diagram of A. We have the weight of A going down, and then we have a T going to the left, up and to the left, and T going up to the right. Now, is this an angle problem or a ratio problem? Are they giving us distances or angles? Distances. So Lucas, we have to figure something out here. They give us the vertical distance and they say it's y. But what's the x distance? Half of 10. Does everybody look up there? Y is the x distance. Y is the distance from here to here, 5, and y is the distance from here to here, 5. Lucas, why did you assume that?
Because weights don't usually sit off center when they're hitting the road.
Okay, and they also say it's free to rotate, it's free to move, right? So in the end, it's going to come down to the center. So we have the distance 5 on both sides. What's missing from the axis, David? What's missing from the free body diagram? So here's our free body diagram. So looking on the other side, we've done a ton of setup problems already, right? Look on the other side of that sheet. What's the next step after doing all the setup and drawing the free body diagram? Finding the components. Okay, so let's think about this. So, shut this guy off. So we have, we're looking at tension, right? So tension is equal to the magnitude times I and the J part. Since I've done this problem already, I know it's going to be complicated, but let's look at the complication here. So how do I find the component of T? Well, let's do let's do the left T for now. The T on the left, so we have the right signs. So we have a triangle, right?
Yes.
Of a y and a 5. So what's the hypotenuse here?
Y squared plus Y squared.
25, 5 squared plus y squared. So what's the x? -5, right? And the y is the y is y over radical 25 plus y squared. Doesn't this look a little, is it newtons or pounds? This looks a little too complicated for me to have in my denominator. Could you imagine that the algebra is going to be intense? We might have a quadratic equation or something. We don't want to deal with that. It's going to take too long to solve it. So what's the other option? All along, when you came from physics, you always did angles, 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 angles. And I said, well, if they give you distances, use distances because it's an extra step to find the angle. And it takes longer. In this case, though, they're giving us distances, but there's an unknown there. It's going to complicate the problem. We don't want to use some funky thing like this in the denominator. So what should we do instead? Use an angle. So instead, we're not going to do this. So just remember this, that whenever you have an unknown distance, you're going to want to use an angle. So I'm choosing problems in class where there's something in there that if you get exposed to, it's gonna help you do other types of problems. So if one of the distances is unknown, go to angles. Because it's probably gonna wind up where there's a sine theta or cosine theta or something, and it's gonna be able to simplify much easier than trying to deal with radical 25 plus y squared. Let's go back to this area right here. We learned there's one unknown, we only need one equation, and we're using one body. Which equation are we gonna wind up using?
Some of the forces in the line.
Some of the y's, right? Does some of the x help us at all? That's all it's saying is the sum of the x's is that this is gonna, the x component of t is gonna equal to the x component of tx. It's not gonna help us at all. So we're gonna have to do a sum of the y. So rather than setting up a component, since we only have one equation to do, why don't we just go ahead and do some of the forces in y? Okay? So some of the forces in the y, and actually, if we change the angle, I'm gonna use, let's just, you guys watch what I'm doing here? I'm gonna instead use this angle, which is theta y. Is it the same on both sides? Why am I doing that?
So that you're not getting anything.
So I could just use cosine, actually. So I could use the cosine function, because I know cosine's always gonna give me better answers than the sine. So some of the forces in the y is t times what? The cosine of theta y. And there are two of them, right? Minus WA equals 0. So 2t times the cosine of theta y minus WA is equal to 0. What's t? 75 times cosine of theta y is equal to WA. What's that? 50. And in the end, theta y turns out to be, what is that, 2/3? So it's about 70. What is it? What'd you get? I think it's 70.53. Did somebody get that yet? I could be wrong, I just did it in my head. Yeah, you got it? Okay. So then, but is that the answer? Go back to the find. What did they want to find? Did they want you to find a theta? No, they wanted you to find a what? Y. So we had 5 in the x, we had y in the y, and then it's this angle right here, that's 70.53. So in that case, it would be tangent of 70.53 is equal to 5 over y, and y turns out to be, this one I can look up, so solve for y, 1.77 feet. Okay? Let's start from the beginning. So we read the description, we wrote what the given information was, we wrote down what find was, we looked at this, we used the principles we know about pulleys with continuous cables to actually decrease the number of unknowns. We might have had T1, T2, T3, but we knew that it's all the same T. And then we also reduced the number of unknowns by knowing that T going up is balancing the weight. So in the end, we only had one unknown. We knew we needed one equation, we needed one body, We picked body A because all the forces are converging now, which means those forces are concurrent forces. It was a problem given with distances, but one of the distances are unknown. It complicates the math to have an unknown distance. So instead what we did is we used an angle. I chose, and because we decided, since we only needed one equation, we decided that some of the forces in the x is not going to help us. So we did some of the forces in the y, and since I knew I was using the y, I decided to put the angle up here instead. Solve for theta y, and then I wound up getting a y value. Did we find what they wanted us to find?
Yes.
Yeah. Okay, questions? Read that.
When we find for theta y, we rounded the angle.
Yeah, and probably, and actually, didn't we say, what did we say? What was the rule in this class on angles? How many decimal places? One. So I shouldn't have put that third one in there. And we are rounding.
But it's okay to round it?
It's fine.
Okay.
Because in the end, as an engineer, we have factors of safeties that we're gonna apply, so it's okay.
What about for distances, like how many distances?
I would carry that out, but if you round it to 1.8, I mean, I wouldn't take off points. But don't round it to 2. Right, that's a little too much. What we can do is, just like with forces, what was our rule on units, decimal places and forces? One more than given, right? What distance did they give? They give us 10, right? So no decimal places, so 1.8 would have been totally fine if we follow the same rule, 1 decimal place more. Rachel?
I did all in the thing, I get 1.6 then.
Okay,
Is that?
and that's okay. If you're, typically you guys aren't like clearing your calculator, you're just continuing and it's fine. When I check your work, I do it with the calculator too. So in the end, there's gonna be a range of correct answers, whether you continued it in your calculator or stopped. Okay. I think that you have, those of you with the more fancy calculators, you could continue a lot more than one of those cheap calculators where you kind of have to clear it and start, and you might be introducing more rounding errors. Good questions. Other questions? Okay, let's go on to another problem. And is this okay that I'm solving them on paper? Do you like it like this rather than me doing it on the board?
Yeah.
The way they are in the quizzes,
Say it again?
the way they are in the quizzes, like this.
Say that again?
To solve them the way they are in the quizzes is nice.
Okay. I'm gonna put this guy back on. Okay, 2D or 3D? Angles or ratios? Ratios, they're giving us distances. Okay, you wanna do the setup again?
Yeah.
On your own? Okay.